This is the section 3.3 podcast. Let's go on to Galileo. And Galileo argued that we're going to talk a lot about friction. And what he said was Galileo argued that only when friction is present, as it usually is a force needed to keep an object moving. Remember, we just said that the ancients basically felt that you had to have a force to keep something moving. So, now, Galileo is probably up there with scientists in history, and he really had some really important ideas, and his important ideas were suppressed, and we'll talk about that in a minute. But his biggest thing was he was demolishing the motion that force is necessary to keep an object moving. And here he is scolding Aristotle in this cartoon. So let's talk about friction first. Friction is the force that acts between materials that touch as they move past each other. And here's a man moving a box across the floor, and you can see what's been done with this picture is this part here is magnified, and you can see that the floor and the box are not necessarily perfectly smooth. Nothing is perfectly smooth. So, what friction is when the irregularities in the surfaces of your objects are touching. And you can see in that picture we do have irregularities between the surfaces. And like I said, even very smooth surfaces have microscopic irregularities that will obstruct motion. Yes, some things have less friction than others. They're smoother, but everything does have some friction. And if we had no friction, then a moving object would need no force whatsoever to remain in motion. A good example of something that gives you friction are your fingertips. These are irregularities in the skin surface that help you grip things. They cause friction. If you think about it, where do you have fingerprints? You have them on your fingers, something that you're trying to grasp, something you need friction to grasp. So Galileo tested his idea about objects not needing a force to remain in motion by rolling balls along plane surfaces tilted at different angles. Essentially, he used ramps, and ramps which we will call a inclined plane. So he found that a ball rolling down an inclined plane speeds up. One that rolls up an inclined plane will slow down. So if you let's say you start on a bicycle and go downhill, you're going to speed up. And when you reach the bottom of the hill and you start going up a hill, you're going to slow down because you're being opposed by gravity. But he also found that a ball rolling on a smooth horizontal plane has almost constant velocity. In other words, it doesn't really slow down all that much. And here it is in graphical form. As it goes downward, its speed increases. As it goes upward, the ball moves against gravity, so its speed decreases. But an object with no slope, would the speed change? Well, if it speeds up going downward, and then speed decreases going upward, then with no slope would logically mean that there would be no change. So, Galileo said that if friction were entirely absent, a ball, theoretically, would move horizontally forever. So no push or pull would be required to keep it moving once it was set in motion. So Galileo used another line of reasoning to look at this. What he did was he took two inclined planes and he put them facing each other. He released the ball down one of the planes so it would roll up the other, and he found that it nearly reached the same height when it rolled up that second plane. And the ball tended to attain the same height even when the second plane was longer and inclined at a smaller angle than the first plane. So look at this. He drops the ball here at this position. It goes down, comes back up, and it almost comes up to the same exact height as its initial height. Now all he did here was he made this longer, and he made this he actually didn't make it longer, he just made this shallower. It still reaches the same height. And so in theory, what would happen here? It would probably just theoretically go on forever, the ball. So if the angle of the inclined second plane were reduced to 0 so that the plane was perfectly horizontal, only friction would keep that ball from rolling forever. So what he said was it was not that of the nature of the ball to come to rest, as Aristotle claimed. It should just keep on going. So this is the tendency of a moving body to keep moving is natural, not to be at rest. And every material object resists changes to its state of motion. So this property we call inertia. This is the property of a body to resist changes to its state of motion. And it's called inertia. That's a very important word. Now, unfortunately, Galileo was persecuted for his beliefs, and he never really got the credit due to him, and his ideas were suppressed. And this is him facing, I believe, the Spanish Inquisition, which was part of the Catholic Church. So let's do a couple of thought experiments. A ball is rolled across a countertop and rolls slowly to a stop. How would Aristotle interpret this behavior? How would Galileo interpret it? How do you interpret it? So Aristotle would say that the ball stops because it seeks its natural state of rest. Galileo would say it stops because there's friction between the ball and the table, and that friction brings the ball to a stop. Now, for you, hopefully you're going to agree with Galileo that it's all about friction. So according to Galileo, when is a force needed to keep an object moving? Galileo argued that only when friction is present, as it usually is a force needed to keep an object moving.